Okay, we're getting back on our 45 stroker motors. So this is the mock-up motor here. This is another mock-up. We were doing the mock-up of the crank clearance in here. This is another set of flywheels here. And this is a set of WLD racing cylinders, or street cylinders. It's a WLD, wasn't it?
WLD.
Yeah. This is my mock-up motor for clearance checking. So this one here, I got a dome piston I made, and this one here's got a stock piston which comes up just a little bit more than it's supposed to. It's supposed to stop like right there, and it's got a little bit more pop up than stock. And this is the one I cut the 45 cylinders out for the K model intake manifold, which I need to duplicate also on the other motor. Alright, here, you can hold that. See if I can get this thing apart. Now this is one size bigger than your manifold, because you have the street bike. Now this has a Sportster crank in here, not a 45 crank. Yeah, that came out. Okay. Which pistons are yours? How much bore you got?
I have no idea.
Whatever fits this hole. You have to even fit in this hole. 2791. Let's see. I'm gonna guess we went with that one for you. That's 804. Here's your stock. $801. So we have to hone these out to match this set here. So these are not for you. Which one is this one? $804, $804, $809. So these are 5 over. These are 5 over for you, not 5 over Harley. You know the difference?
These are already over.
Yes, you're way over. You are 50 over right now. This makes it 60 over when you put these in. It looks almost stock. A little shorter, huh? Perfect fit. Look at that. It's almost like it's made for your application. Look at that.
Pretty nice. Right flush.
Well, you're going to have a gasket here and a head gasket. Probably zero deck right now, close to it. I think we're pretty much zero deck. So whatever gaskets we use, that'll be your piston clearance. So, alright, so now we gotta make this fit on your motor. So see how much these are cut here? See they're cut out? It's for your rod clearance for the stroker crank. So your cylinders need to be cut. See the difference? So we gotta cut these out to fit here. So see the difference between a 45 cylinder here, stock one, and a WLD cylinder. See how much thicker these things are? See how thick they are? So these will cool a lot better. It keeps the bike from doing wheelies too because they're a lot heavier. Alright, so we're going to have to cut this out to match that. And then the biggest thing is we're going to have to cut the flywheel, the case out also to match. To match what you've got. Now this is your intake cord here. See the size of yours? See the difference? So this is UL, this is K model, panhead, knucklehead. So the 45 is the next one below this, you're in between. So you have a big cord for 45 but small compared to the other motor's going to have in it. Yeah, that one's a little tighter. So there's a stock piston. A little difference in sizing. See how that top ring was poked all the way out of the cylinder, see? And this here is clearance because the flywheel's getting way down low. So it comes way on down. Which we assume there's clearance for. I haven't checked yet though. We still have a lot of stuff to check. Oh. No. Appears to have clearance there. That's good. So we have it cut away enough. This will make the flywheel balance better too, being lighter. That's always a good thing. Now we get to pull this whole motor apart. So we do the mock flywheel checking. Let me see, get the tools over here. Actually, I have to take that off. If that can come off. That comes off the unit. Jeez. Full mock-up there, it was tight. Maybe they rusted in from sitting. I don't remember putting in that tight. Must have been stronger back then. You got the tall oil pump in your motor, don't you?
Looks like that one.
It's a flat one. You know, the one that sticks up way high.
Oh, I don't know.
You don't remember?
I don't know.
It's your motor.
It's been here since
Last week?
Yeah.
Last year? Last decade? Last millennium?
yeah.
How long has it been here?
May 6th of 12.
12? 25 years.
Almost 6.
Okay, not quite. That's being generous. Oh, yeah. Hard putting those parts in there. Now these are Sportster rods, so you have to do more clearance because they're bigger. They're wider in the beams than a 45 rod. So you get a stronger crank, but it's light enough to have the stuff on top. Jeez. That was on there. I don't think those are going to come up. So we put them in tight. Okay, where did I put my tool for doing this? Gotta go hunting. Not there either. This is buried in here somewhere, dude. Great. Appears to be missing. Kind of needed to. Oh well. I'll have to hunt that down. See, these blocks are in here tight, so they're not moving. I like to sand them down so they fit in the holes easier. I'll have to deal with that later. Somewhere I got a tool for pulling that. Oh, that came off nice. These appear to be hot rod cams. These are the ones that were made by the guy that sold your cams. So this set must be the other set. So they're hotter. Tail lobe's bigger and fatter. So this is the next step up. That's for the guys that really want to go fast. Okay, that does not come off, so that means we got to pull the... See, if you don't pull this gear off, this gouge pump has to come off because you can't get the crank out with that in there. That appears to be a tight fit. Like my official spacers. Need that many. So we got Timken bearing in here. So in order to use this, I have to make some kind of a plate to go there and hold this all together. That didn't get designed yet. Jeez. You know, less nuts on there. Look at that. That cheap crap. Now the crank can come on. Looks like brand new hardware. See, my motors only use the good parts. Hopefully your case is going that tight. See how this one's a little bit looser? It's not quite right. These numbers actually match. That's rare. See, it's a 43 WLA. They never made that. Jeez, it's long-winded. Okay, and this is supposed to be pressed on. Do you think I modified that? Yeah, it looks like a Sportster. Appears I didn't modify the bearings. They're still tight. Okay, see the rod clearances here? See when it comes around. See how tight it is? Kind of almost matches.
Pretty close.
See over here, does the same thing. See the wrist pin has to be in the center where the cylinder is. That's how you know where you're at, clearance-wise. Now, ideally you want to have about 50 or 60 thou in here. But in the real world, if you got 30, you can use it. You can see how the pistons get pretty close to the base down here. Now if you want to know how much piston clearance we had on your piston, these are the ones I made up. close it gets. These ones I had made for you.
Oh.
See how generous we are?
Yeah, weeks away.
So basically a piston not quite to the point here. Now this doesn't fit in your cylinder, that's why I can't use your cylinder. So your cylinder right here. So so you got about a 200 thou gap between the cylinder and here. The piston was about here, so the piston's actually going to pop out about a 1/16 out the bottom of this, even though it's shorter than the other piston. So, because this has got a little short skirt. So I had the piston made, I had them shorten the skirt up, because there's no real reason to come out the bottom a whole bunch. That's still enough skirt for the bore, plenty of clearance. I mean, plenty of support on the piston. One advantage is that allows you to have more windage, so when the pistons go around, there's the oil and air can get in and out easier, so it doesn't suck up as much horsepower. They found that on those LS motors when they ran steel cranks and them things. On my race bike, what I used to cut the center of the flywheels out over here. I cut the flywheels out in here for a bigger gap, here, so that way the air would have room to go between the flywheels when the piston went up and down at high RPM. Always thinking ahead. Okay, so this has to get pressed off. It's kind of surprising because I thought the thing just slipped on there, but obviously not. Time for just a fallout. Just pressed in there. So see, I modified it. I might actually put a snap ring in there. I don't remember doing that. Yeah, maybe. I don't know if I got an actual snap ring in there or not. Probably don't. Alright, so this is a full Sportster crank. No conversion crank, that's a Sportster crank. And this one over here is a 45 crank. Lost all the bearings. See, we didn't need quite all those bearings in there. So. Not for a mock-up. I only got 4 bearings out of. That's all we needed, wasn't it? So there's that washer we had to make. See. So on this motor here, what I did was I took the race and I cut off until the snap ring is almost gone in the hole. See over here. See, it's got a groove in here. So I cut this away on the lathe until it was almost gone. Now this one here, the groove is too thick here. This will not ever cut away. This is an import case from Dixie. It's made in India. Can't use those. They're cut too deep. This one here is a genuine Harley race. So see, I got half the bearing here to go across. So this roller here, when it runs across it, will still be supported even though it's missing part of it here. There won't be a spot where it's really going to dig in very hard and cause a problem. This is a heat treated washer that goes against the flywheel to protect it. And this is a spacer that holds the bearing and the washer onto the bearing itself. Cage and everything recesses into here. Shows some clearance on that. And this actually goes on the flywheel, and this is clearance in here. That's how much clearance I run, about 15 or 20 thou. Because this has to be held on by the flywheel. Right here. This is supposed to press up on top of that. That way the washer and the bearing will stay in here where they belong and not move around. But I have to cut this out to put a washer in there, which isn't in there yet. More work to figure out. But these have the little 45 shafts in them that take the 45 bearings. This whole setup right here. Goes like that. So this gives us a thrust bearing on both sides of the case, so the crank can float back and forth and not eat up the thrust bearings like a stock one does. Whereas this one here is a Timken. This bearing here holds the crank centered. That's what the advantage of the Timken is. And then this side over here is a floater. It never touches. And see, the bearing here is held by the shaft, whereas on this motor the bearing is held by the case. See the snap ring down there? That's what keeps the bearing in. So they kind of reverse how things work. So we're mixing and matching components, which all has to be figured out a little bit better than what I got. So I need to make these in different thicknesses. Fun. But for your case right now, we're not using this. For this. Okay, see all this here? So all of this here I got to cut into this. I got to cut out these baffle plates here, cut them all out. Then I got to go ahead and cut all these in here, all these cutaways. And I got to do it on both case halves, so that we will have clearance for the stroker crank. And this one's over here. Has to have the same thing done to it. Extra parts. So this has to have the same thing cut out of here. And in your cases, which are over here, have to have the same thing done to them. Except you didn't clean your cases yet. So I guess tonight's project is to get the cases cleaned up. Then I get to my milling machine here set up. Probably that angle plate down here. I'll get to bore some holes. First thing I do is cut the holes out here, all the way through, like that. And then I gotta make up some kind of a template, so I know exactly where this line is, and I gotta cut that line in here. So I have to make me a little template that goes from these holes here. Figure out how I'm gonna do that. Probably should make it a piece of metal so it'll be It won't float around too much. Then I can do multiple cases relatively easily. So right now we're doing two of them in a row, so we have to make it work. Alright, so that's where we're at for now. So it'll be a fun weekend working on the 45s.